Okay, we are going to look at how to balance chemical reactions or chemical equations. So because of the law of conservation of mass, it states that matter cannot be created or destroyed. So when we are writing out a chemical equation, we need to make sure that we have the exact same number of atoms in the reactants as we do in the products. Now we can never change these small little subscripted numbers, we can only change the numbers out front. So to balance a chemical reaction or chemical equation, you just start with one element and then sort of go through the reactant side and then the product side to make sure that they're equal. Some people find it helpful to make a little chart and list out each of the elements and then write them as you are counting. I'll do that for this one, but for the first one, we'll just kind of work through it. So I just start left to right. I look at my hydrogen and I see I have 2 hydrogen here. And then I look on my product side on the other side of the arrow, and I have 2 hydrogens there. So that's already balanced. So then I move on to my oxygen. I have 2 oxygens, but I only have 1 oxygen here. So I need to make 2 oxygens. Now I can't go and add a 2 here because that's going to change it to hydrogen peroxide, which is not the same as water. So instead I add a 2 out front. Now I have 2 oxygens, but I've changed my number of hydrogens. I now have 4 hydrogens. So I have to come back to the hydrogens on the reactant side and make 4 hydrogens on this side by putting a 2 out front there. So now it's balanced. Now this second one is a little bit harder, so I'm going to move on to this one and then I'll come back to the second one here. So here we have iron, and chlorine produces iron 3 chloride. So again, I would just start with my iron and I say, okay, 1 iron, that's balanced. And then I move on to my chlorine. I have 2 chlorines in the reactants, 3 in the products. So I need to make those the same number, but there's no way to turn 2 into 3 or 3 into 2 using whole numbers. You can use fractions, but we're just going to balance using whole numbers. So instead of trying to turn 2 into 3 or 3 into 2, we turn them both into the lowest common number that they go into, which is 6. So to turn this chlorine into 6, I put a 3 out front. To turn this chlorine into 6, I put a 2 out front. And then I've gone and changed my number of irons. So now I have 2 irons on my product side. I need to come back and put a 2 in front of this iron to make it balanced. So that's the way to balance without using a table. If you want to use a table, you have your reactants and your products, and you just go left to right until you hit the arrow, writing down each element that you run into. So we've got potassium, manganese, oxygen, hydrogen, chlorine, and then we hit the arrow. And then all the ones on this side are going to be the same as the ones that were on this side, just in a different order. So I have 1 potassium in my reactants, 1 manganese in my reactants, 4 oxygens in my reactants, 1 hydrogen, and 1 chlorine. So then I look over at my product side. I have 1 potassium, I have 1, 2, 3, 4, 5 chlorines, I have 1 manganese, I already did my chlorines, I have 2 hydrogens, and I have 1 oxygen. So now we need to make all these numbers the same. So potassium and manganese are good right now, so we'll move on to the oxygen. We have 4 oxygens in our reactants, and only 1 in our products. So let's go and fix that. So to turn this into 4, I'll be putting a coefficient of 4 out front. So that changes my oxygens in my products to 4, but it also changes my number of hydrogens now to 8. 4 times 2. So now I need to go back and change my number of hydrogens in my reactants. I need 8 hydrogens in my reactants. So that's in this hydrochloric acid here, I'll need to put a coefficient of 8. Now the only thing that's unbalanced is our chlorines. We've changed our chlorines on this side to 8 now, but we have 5 on this side. Now we have a little bit of an issue because we have chlorine in 3 different places here. Now when you run into this situation where you're trying to balance one element and it's in several possible places, check and see if there's one spot where it's just chlorine, so we're not going to affect anything else. If we change this, we're going to affect our potassium. If we change this, we're going to affect our manganese. But if we change this, it's only going to affect our chlorine. So right now we have 3 chlorines on this side, not including this one. So we need 5 more to have a total of 8. So we need this chlorine to equal 5. But since it has a subscript of 2, that's not going to really work. So you have 2 options here. you can put a coefficient of 2.5 here. 2.5 times 2 would give you 5. Or you can go and double all of the numbers that you already have in there and then figure out what you need for your chlorine. So if I were to do that, this is an invisible 1 right now, it would become 2. This is 8, it would become 16. Our invisible 1 would become 2. Our invisible 1 would become 2. Our 4, would become 8. And then this one, we'd count up how many chlorines we have now. So we have 16 chlorines on our reactant side, and not including the one we're trying to balance right now, we have 2 plus 4, we have 6 in total here. So we need 10 more here, and it's a Cl2, so if we put a coefficient of 5, that would give us a 10. So either set of those numbers would work. You can have 2, 16, 2, 2, 8, and 5, or 1, 8, 1, 1, 4, and 2.5. Now when you're balancing a word equation, you first need to write out the chemical equation and then balance it. So sodium, whenever you see just one word by itself, you just look on the periodic table and write it exactly as it is, unless it's diatomic. So it's kind of shiny here, but sodium is just Na, and it's not one of our diatomic elements, so we just write it as Na. So sodium, and then you see the word and, means plus, and water, the chemical formula of water is H2O, produces sodium hydroxide. Now this is a compound because it's 2 words and then the and comes next. So when it's a compound, you need to think, first of all, is it ionic or covalent? If it's ionic, you use your common ion sheet to figure out the chemical formula. If it's covalent, then you use the prefixes to figure out the chemical formula. So synthesis is ionic because it's a metal and an ion, or non-metals over here. We use our common ion sheet to determine our chemical formula. I'll just take it out of the plastic so it's not so shiny. So we look on here for sodium, sodium's down here, and we look for hydroxide, which is over here. This is an Na plus and an OH minus. Where did it go? Oh, right there. OH minus. So they go together 1 to 1. Now it might be helpful for you to write here the ions and then put them together here. When you're writing your balanced chemical equation, there should be no charges. You only use the charges to help you figure out the chemical formula. There should be no floating charges down here. And this is just hydrogen. So this is where we would look on our common ion sheet. We don't use charges. We don't try to make it into a compound or anything. We just look at our periodic table and say, okay, hydrogen is H. But then always ask yourself, is that one of the diatomic elements? And hydrogen is one of the diatomic elements, so we need to put that little 2 there. Sodium, it was not, so we don't put a 2. But since hydrogen is, we need that little 2. Okay, and then now we go and balance. Now, sometimes when you look here and you say, okay, this is H and OH, and I have an H2O over here, it might be helpful to think of H2O as HOH. That can help you with your balancing. So we check our sodium. We have 1 sodium, 1 sodium. And if we think of this as HOH, our H, we have 2 over here. Our OH, we only have 1. If that's confusing, you can just look, okay, I have 2 hydrogens, and I have 3 hydrogens over here. So how am I going to fix that? Well, I need some more hydrogens. So I'm going to put a 2 in front of this H2O here, which, if I'm thinking of it as HOH, that might be more helpful because now I have 2 H's, which I already have over here, and that tells me I need 2 OH's. Well, I only have 1 OH over here, so I need to put a 2 here, and then I changed my number of sodiums to 2. Now, if you're counting up just the atoms, this works too. So I have 2 sodiums, 4 hydrogens, 2 plus 2 hydrogens, so 4 hydrogens, and 2 oxygens, 2 oxygens. So now it's balanced.